Hey guys, I just want to take a little bit and talk through the first few flat slides of the Module 6 materials. I'm in my fuzzy jacket because it's cold outside, so I decided to go with the mood. All right, so let's get into it. So today we're talking about graphs of linear functions, and so I just want to kind of remind you of a few things. So one, we define a function or relationship between quantities to be linear if those quantities are related by a constant rate of change. So linear implies constant rate of change, and the reason for that is because when I graph those two quantities, we're always going to get a line. Now, in terms of the line, we would say a linear function is increasing, something like this, if the output values are increasing as the input values increase. So as my input is increasing, my output is also increasing. And so essentially my function is increasing if I have a positive constant rate of change. Conversely, we would say that the linear function is decreasing if the output values are decreasing as the input values increase. So as my input is increasing, my output is now decreasing. We have a negative rate of change. And so that's always important to keep in mind because you want to be able to picture if you have a positive croc, your graph is increasing. If you have a negative croc, it's decreasing. So let's take a look at this example. So it says a local construction company purchased a piece of equipment that had a value of $80,000. For accounting purposes, they depreciate the value by the same amount each year. So the graph given represents the value of the equipment with respect to the number of years they've owned it. So is the function increasing or decreasing? You should be able to look at that and be like, oh, it's decreasing. Right, as time increases, the value is going down. So negative rate of change. The change in output is negative, the change in input is positive. It says to determine the constant rate and explain its meaning. And so what we want to do is to find the constant rate of change, we need to have 2 points. And so you want to pick 2 points on this graph that are just easy to see. So I picked, let's say 0, 80,000 up here. And then I picked this point here at 4, 50,000 just because I could like see it where it crossed. I'm going to put those two values into a table because I love me some tables. And I'm going to find the change. So I'm going to do 4 minus 0 is 4. 50,000 minus 80,000 is negative 30,000. Change in output over change in input. I'm going to get negative $7,500 per year. So every year we're decreasing the value by $7,500. All right, let's keep going. So part C says to write the linear function that gives the value of the equipment. So remember with my general form, I just need to have a croc and I need to have a reference point. In this case, I have my vertical intercept. And so even when I write it this way, it's still going to simplify. By the way, always divide your variables. I include units. So here I said years and here I said dollars. So make sure you include your units too. Part D says identify the vertical intercept of the function. Well, that's easy. We already have it. And explain its meaning. And so it's always where my graph crosses that vertical axis. So 0, 80,000. So when you first purchase the equipment, it has a value of $80,000. Part E says to determine the horizontal intercept and explain its meaning. So now, the horizontal intercept is where my graph crosses the horizontal axis, which is where my output is 0. So I'm going to take my function, set it equal to 0, and solve for t. So subtract 80,000 from both sides, divide by negative 7,500. I'm going to get t equals 10.67. So my intercept is saying when the input is 10.67, the output is 0. And so in terms of meaning, we would say 10.67 years after purchasing the equipment, it has a value of $0. All right, finally, list the practical domain and range of the function. I tend to think of domain and range visually. And so when I think of that, I'm going to think of my graph over here. So domain is my set of meaningful input values. So really that's going to start here at 0 because it doesn't make sense to talk about the value before I bought it. And it really doesn't make sense to talk about the value after it's decreased to $0 because it's not like the value is going to go negative. So my domain is going to be between 0 and 10.67 years. My range is output, so it's going to go from 0 up until 80,000. Even though the value is decreasing, we still list the domain from the smallest value to the largest, just so you guys remember that. All right, part G says, suppose the company had instead chosen to depreciate the equipment by $10,000 each year. Explain how this would affect the graph and sketch what you think the new graph would look like on the same axis. So I'm not going to do that here in my fancy PowerPoint, but you can do that on your paper. Essentially what we would see is the initial graph is decreasing. This one would be steeper. It's decreasing by a larger value each year. And so if I write my function, I can't use any reference point now, by the way. I have to use that 0.80,000 because my new depreciation value is changing all those reference points. Essentially, I could write my function like this. It's going down 10,000 per year, but we still started at 80,000. And we would say that the value reaches 0 more quickly, right? If we're losing $10,000 each year, we're losing value more quickly, so we would get to 0 faster. Which you should see when you make your graph, your horizontal intercept is now at 8,0 as opposed to 10.67. All right, if we keep on going, question number 2 says for each of these graphs, identify whether the function is increasing or decreasing, so whether my croc is positive or negative. Determine the croc of the function, so and hint, pick 2 points on your function just like we did and find your croc, and then choose a point as your reference point and write the formula. So for this first graph, you just need to pick, so first off, it's increasing, right? As my input increases, my output also increases. You need to pick 2 reference points. I'm going to find my croc, so I picked 0, -5 down here, and then I picked, I don't know why, I picked 4, 5 here. So I found my croc was 2.5, and when I write my formula, it's just going to be right there. You could write it again just as 2.5t plus 5. That's totally fine. Same thing, okay, second one, so increasing or decreasing. This is now decreasing because as my input's increasing, the output is decreasing. So a negative croc I would expect, so you should always make sure. I picked these 2 points. Again, you could pick different ones. You find your change in input, you find your change in output, you divide, you get -3. Pick one of those 2 points as your reference point, and then write your formula. All right, so really the key, if you need to write a function, is pick 2 points on your graph. Once you have those 2 points, find your croc. Once you have your croc, pick one of the points. And then finally, on the last one, this is actually neither increasing nor decreasing. So, hey, I tricked you. My croc in this case, even though I picked 2 points, is going to be 0, right? Because I picked here at 0.6 and I picked here at 4.6. So when I find my change in output over change in input, I'm actually going to get 0, which is fine. But if I go to write my formula, notice that when my croc is 0, even if I pick this as my reference point, 0 times anything is 0. And so really this first part right here just goes away, and I'm left with y equals 6. So essentially what we're saying in this case is my output, y, is always going to be 6 no matter what the input is. So this graph is an example of a horizontal line. So a horizontal line is a function. It's boring, but it is. Right? For every input, there's one output. A horizontal line is always going to have a croc of 0, right? It's neither increasing nor decreasing. And so really what that means is the formula for a horizontal line can be written in the form of output variable equals whatever the number is. Because essentially we're saying, hey, no matter the input, the output, always the same. So like on this problem, no matter what the input is, the output is always 6. So just keep an eye out when it comes to horizontal lines, and that their constant rate of change is going to be 0.